Okay, so given you y equals to x cubed minus 3x squared plus 3x plus 1. Find stationary point. Before we get stationary point, we find critical point first. So how to find critical point? dy dx. So differentiate this with respect to x. And we need to let it to become 0. So this quadratic is multiple of 3. Simplify it first. Divide by 3. Then only you start factorize, or not, your factorize will not same with your quadratic. No, this one is minus. So you only have one critical number. Then after we get this one critical number, substitute inside, sub into y to get coordinate. So y. Two. Yes, 2. So 1, 2 is critical point, or we can call it stationary point. Answer the first part first. And then determine its nature. So we have to determine this critical point or its stationary point, whether it is maximum or minimum, or maybe it will come to infraction. It will, if you got result maximum or minimum, then okay. If you don't have result, so it might be infraction point. So you have to prove that it is an infraction point. So what's the result here? If we doing the test, using second derivative test, and when we substitute x equals to 1, this second derivative test come to 0, so no result. Normally we just have two results, greater than 0, concave upward minimum, right? Is second derivative test. Less than 0, concave downward, this is maximum. When it exactly equals to 0, no result, no conclusion can be done. It might be, it just might be infraction point. So to prove that it is infraction point, we have to prove the concavity change if using second derivative. Or not, you have to, or not, you're using first derivative, you have to see the tangent. Is it going up, or going down in that result? So either one test to be go. So we continue to prove that what is its nature. So this one is no conclusion, no result. So I continue with second derivative test. So do your table to see before 1 and after 1 to see the concavity got changed or not. Interval, we want to know x before 1, less than 1, x after 1. For d2y, dx squared. So that's result, that's value, and then d2y dx squared result, then conclusion. So less than 1, we can choose 0. More than 1, we can choose 2. So 0 put in negative, so concave downward. 2 put in positive, concave upwards. Yes, concavity change. So the point means point exactly equals to 1. That is a infraction point.